Hi students, myself Raghuvamsi. I am here to teach the total thermal part and heat transfer. The total thermal part divided into three topics. One is thermodynamic basic concepts, and second one power plant and IC engine, and third one refrigeration and air conditioning. First, we will start the thermodynamic basic concept. Right. Now let us see the weightage in gate marks in thermodynamic basic and power plant IC engine. The average marks in gates or in gate exam are 8 to 10 marks. In refrigeration and air condition, we can expect 2 to 4 marks. Now, what are the reference textbooks for thermodynamics? For thermodynamics, the reference textbook I prefer for concepts. Sengel and Bowles. Now, in this textbook, he explained the concept in practical manner. For numericals, refer PK Nog textbook. Okay. And my sincere request, please maintain running notes because it will help you in quick revision. Anyway, we provide material in our Telegram channel. Right? Now, before entering into this subject, thermodynamics. What is meant by thermodynamics? As we know that thermo means heat and dynamics means study of motion, or simply we can say power. Okay, right. First of all, we have to ask ourselves three questions before starting this subject. Now, what are the three questions? Why we are studying this subject? What is the use of this subject? And where we are going to apply this subject knowledge? Let us see in practical manner. Okay. First, we learn the basic concepts from the thermodynamics. Now, in industries, example in power plants, or maybe in developing IC engine industries, motor industries, there the scientists will develop some machines. Okay. Those machines must and should be in efficient manner. Is it? Now, as and as an engineers, our work is we have to analyze the machines, we have to learn, analyze, and our duty is to improve the efficiency. As we know, the most of power plants, thermal power plant. What is the efficiency? The efficiency of thermal power plant is only 28 to 30%. Do you know that one? Means almost 70%, almost 70% is losses. See here, how much energy we are wasting, how much energy becomes useless. Okay, right now as an engineer we have to improve this efficiency. That is the main role of an engineer. To improve the efficiency, we have to learn the basic concepts very clearly, right? Now let us discuss the chapters in thermodynamics. First, basic concepts. Next, zeroth law of thermodynamics. Next, work and heat transfer. First law of thermodynamics. After that, second law of thermodynamics. Next, entropy chapter. The entropy chapter is very important, especially for gate point of view. Okay. Next, availability. And irreversibilities. Next, properties of pure substances. And last, thermodynamic property relations. Thermodynamic property relations. Okay, these are the chapters in thermodynamics basics, right? Hope you note these chapters. Now let us see the definition. Now definition of thermodynamics. The thermodynamics, it is the science of energy transfer. The science of energy transfer. It may be heat or work transfer or both including, that is heat and work transfer. Okay, the science of energy transfer with the effects on with the effects of properties on system. Okay, right. We learned what is the definition of thermodynamics, but what is the aim? This is very, very important. Aim. The aim of our thermodynamics. The main aim of thermodynamics is to convert the disorganized form of energy into organized form of energy in an efficient manner. So whatever the mechanism, whatever the machine we have developed, that should be in efficient manner. If there is no efficiency, then what is the use of machines? Okay, right. Now what is meant by disorganized form of energy? What is meant by disorganized form of energy? Here I am saying the disorganized form of energy as a heat and organized form of energy as a work. Why I called heat is a disorganized and work as a organized form of energy. Now let me explain in practical manner. Okay. Let us see why I called heat is a disorganized form of energy. Okay. Let us take a wood and supply some heat. What happened? Due to internal energy of this wood will give some heat energy. Now let us say what is the direction of heat transfer from the wood? The heat transfer in any direction. Hope you understood. The heat transfer by burning the wood in any direction. It move in randomness way, in all direction. Okay. Now whatever the heat developed by the wood, that heat cannot be converted as a work. We cannot convert this heat, directly this heat into work. Okay. This is very, very difficult. Why? That is the reason the heat is a disorganized. It is a disorganized form of energy. We cannot convert that heat into directly work. Now let us see how we can convert the heat into organized, that is work. How and why I called work as a organized form of energy. For example, let us consider an IC engine. All of you know that IC engine parts. This is cylinder, piston, connecting rod, crankshaft, and the output is mechanical work. Right. We know that after combustion process, there will be a lots of heat generation. Now due to that heat generation, the pressure forces These are the pressure forces exerted on the piston head due to the combustion, due to the heat. I can say the heat pressure forces developed or exerted some pressure on the piston head. Okay. Now the piston will move in downward direction. That linear motion of piston is converted into rotational, that is mechanical work output. See here also same heat, and in this case also same heat, but in second case we are converting the heat is a disorganized form of energy. We are converting the disorganized form of energy by using some constraints into organized form of energy, that is mechanical work. And why I called work as a organized? Let me explain. See here, the disorganized form of energy, heat, converted into organized form of energy, work, by using some constraints. There must and should be some constraints to convert the heat into mechanical work. Okay, right. Why I called work is a organized form of energy. I will discuss in practical manner. All of you know the bike. Yes. We know that the bike runs with the help of an IC engine. Yes. In IC engine there will be combustion, power stroke, from that mechanical work. From that we can ride a bike. See here. You can ride the bike whatever the speed you want. Yes or no? 60, 70, 80, 90. Yes. You can take left hand, you can take right side, right. You can stop wherever you want. What it means? It says that the work output from the IC engine, the mechanical work, is in our control. That is, we can ride whatever the speed we want. We can take left turn, right turn. We can stop wherever we want. That is, the work is in our control. We can use that in a systematic way. Understood? That's why I called work is a organized form of energy. This is the beauty of thermodynamics. Understood? Hope you understood. Next, let us discuss the basic concepts of thermodynamics. And we can see this example in steam power plant also. First, by using some combustion chamber, by using some fuel products, for example coal. From that the heat is transferred to the boiler. We know that in boiler it stored some water. That water is converted into steam with the help of heat supplied by the combustion chamber. Now the steam having high pressure and high temperature. Now the steam entered into a nozzle. Now what is meant by nozzle? It is a varying cross section of area, or simply converging cross section of area. What is the working principle of nozzle? It converts the high pressure energy into high kinetic energy. Now, with the help of high kinetic energy, the turbine blades, or simply the turbine rotates. With the help of turbine, we can get some mechanical work output that is subsequently converted into electricity. Okay.